Hey, thanks for checking out SGU TV. Today we're going to be talking about the topic of ions inside the cell and how you can remember some of the various concentrations and how it really kind of all makes sense. So let's take this thing that I got here from the internet and let's compare some of the different ion concentrations between the cell, the interstitial fluid, and the plasma. Okay, so the thing is that let's look at sodium first. Okay, sodium we know is a toxic substance. It's a metal, highly unstable. You put it in water, it'll explode. It's a huge problem. Okay. Also, chlorine, right, is a nerve gas, and it'll kill you. Okay, we want free sodium and chlorine levels to be low inside of the cell. That's dangerous stuff. Okay, but then we look inside the plasma and the interstitial fluid, and we see the level of sodium and chloride is relatively high. So how bad can it really be, right? Well, actually, these things are just really electrolytes that are helping to keep your blood system stable and to regulate passage of water into and out of your body. So if you think about it, right, they say if you eat a lot of salt, you're going to swell up, things like that. So just think about it as a kind of a regulatory mechanism type of thing. But just remember that sodium and chlorine levels inside the cell should be relatively low. And it's easy to remember because sodium and chloride are poisonous substances. Okay, well, let's move on. We have potassium over here, right? And we see that the level inside the cell is relatively high. Why would it be relatively high? Well, we remember that we have the sodium-potassium pump pumping out three sodiums and bringing in two potassiums. What happens is that this creates a charge differential, so the inside of the cell cytoplasm is actually negatively charged and the outside is positively charged. You should, just from the basic biology, have a grasp on that. So it makes sense that the potassium levels inside the cell will be high because the cell is constantly bringing in potassium. And it makes sense that the level of sodium inside the cell will be low because it's constantly pumping out sodium. Okay, so this can help you to remember that. Now let's move on to calcium. Okay, calcium is a very powerful enzyme activator. And if you have calcium levels super high in the cell, it's going to cause all kinds of havoc. Also, calcium is used to activate muscles, right? They say drink your milk because it helps you build your muscles, right? Well, calcium, does more than just build bones, but it also is used as a signaling molecule, and it's, you want to have it around, but you don't want to have levels a bit high inside of your cell just floating around. It can actually be highly detrimental. So you can see the number is 0.0002. It's a very small amount of calcium, right? It's not because calcium is toxic. I mean, it is toxic if it's inside your cell because it's activating all kinds of stuff and it's just going haywire. It's basically, just things just go completely out of control. So it's not the same thing as remembering like sodium and chlorine are toxic, but remember that calcium is an activator of things, right? And it can cause all kinds of havoc, and that's why your calcium levels inside the cell should be low. Outside the cell, they should be higher, right? 2.85, right? Relatively interstitial fluid and plasma. Let's move on to magnesium. You can see that there's a little order of difference here. Some different materials actually say that this number is the same, right? Actually, there's another diagram that shows that they're all the same. Magnesium 333, right? So that's a point of debate. But magnesium, it's an important molecule, but as in terms of the difference between the cell, the interstitial fluid, and the plasma, it's not really significantly different to make a real difference, right? So let's move on down to these anions down here. This would be what? This is a carbonic acid, right? So if you think about it, what is carbonic acid doing? As you may have learned, carbonic acid is inside of your blood, and it serves as a buffer. It keeps your blood from getting too acidic or too basic. So, working out, all that lactic acid building up, and then why don't you just die from, the acid levels rising in the bloodstream, it goes out of control when you die. Now you have this buffer that's going to keep things under control. So where do you want your buffer? You want it inside of your cells? No, you want it inside of your plasma. You want it inside your blood where it can, do its job. Interstitial fluid also makes sense. Right between your muscles, there's going to be some free floating fluid around, and you need to buffer that area as well. So it just makes sense that bicarbonate levels will be higher outside of the cell than inside of the cell. Proteins. Well, cells need to use proteins, right? Do you really need it inside your, inside your free floating fluid inside your body? Not really. It's not really doing anything active yet, right? The active cell processes are using proteins, fats, carbohydrates, so it just makes sense that the highest level of protein will actually be inside of the cell. Okay? And I guess the levels in plasma will be higher because sometimes proteins are carrying things around. Okay, they have special shapes, and also that protein can be delivered to different parts of your body. So it just makes sense that the protein will be a little bit higher in the plasma than the interstitial fluid, but the majority of protein should really be inside of your cell. We're almost done. Okay, it's looking good. Phosphates. What are phosphates used for? Well, you ever hear something called ATP? Super important, right? That's how the cell provides energy for its day-to-day, or hour-to-hour, from minute to minute, depending on how long a cell's going to last. But that's what it uses for energy. So where do you need your energy? You need it inside the cell, right? It needs to do these processes. So of course phosphate levels should be high inside the cell as opposed to anywhere else, right? That's really where it's needed, right? You put gasoline in your gas tank so it can fuel the engine, right? You don't put it like on the outside of your car. It doesn't make any sense. You need it where it can do its job. Chlorine, once again, we talked about that earlier, right? It's toxic. It shouldn't be at high levels inside the cell. And that basically covers the anions that are, the ions that are inside your anions and cations that are inside of your cells and your interstitial fluid and plasma, and it just makes a lot of sense. In terms of memorizing the specific numbers, that will be another video, so just stay tuned. Thanks for checking us. Alright, that's it. Thanks for checking out SGU TV. Please make sure to like, comment, and subscribe, and check out our other videos.